morning, everybody. This is Dr. Jingbo Louise Liu from Texas A&M University, Kingsville. Today, I'm going to show you about the rate law determination. So this lecture will discuss three topics. The first one is about reaction order determination, the first approach, and then the reaction order determination and the reaction rate constant determination using graphs. The very last one will be the activation energy determination by using a plot. In this plot, you are going to use ln rate as a function of 1 over t. Three key points: activation energy determination and the rate law determination. Rate law determination, you can have two different approaches. In each approach, you are going to determine the reaction rate order, and then you calculate the reaction rate constant. First of all, let's take a look of your experiments. You are going to prepare different concentrations for one reactant, iodide. Similarly, the second reactant, hydrogen peroxide. You prepare different concentrations, and then you react these two together. So you react these two, and then what you are going to do, you are going to determine something we call the initial reaction rate in moles per liter per second, in molarity per second. I call them rate 1 to 3 all the way to 7. For your reaction order, you are going to assume the rate equals to a K times I concentration, I negative concentration to the power P, concentration of hydrogen peroxide to the power Q. You want to determine P and Q, and then you are going to calculate your K. In order to calculate your P, you are going to use your 12, 2, and 1. You use R2 divided by R1. And then you are going to write it down this equation, R2 divided by R1 related to the concentration 2 divided by concentration 1. And then you are going to cross out the same quantities. K is the same. Concentration of hydrogen peroxide was kept at a constant value by you. Therefore, this above equation will be simplified to the rate 2 over rate 1 equals concentration for iodide 2 divided by iodide concentration 1 to the power P. You simply replace the numbers into this equation, and then you determine your P. Then in order to determine P, you take the logarithm. Therefore, your P equals the logarithm of this ratio divided by the logarithm of this ratio. Meaning, my calculation is 1.99 equals to 2 to the power P. My calculation is 1.99 equals to 2 to the power P. You determine P. So your P equals the log 1.99 over 2. 1.99 divided by 2, take a logarithm. Approximately P is 1. Similarly, you are going to repeat step 2 and 4 to determine your Q, reaction order for your hydrogen peroxide. So you can choose different one. In my case, I choose R6 over R5. R6 over R5, so you determine this equation. Again, you are going to cross out the same quantity K, rate constant at the same temperature. After you determine this rate constant, you are going to also cross out the concentration of your iodide. You simplify your R6 divided by R5 to this equation. Concentration of hydrogen peroxide 6 divided by concentration of hydrogen peroxide 5 to the power P. Again, you replace your numbers into the equation. My calculation is 1.5 equals to 1.5 to the power q. You calculate your q again. Your q is exactly number 1. Therefore, you determine your q and p. In order to calculate your k, you can choose any 12. You can also calculate all of this case for these different 7 12s, and then you take the average. So in my case, I just showcase, we calculate K, use your R1, concentration 1. Again, you simply replace your numbers into your equation. In this case, put your numbers into your equation. So your, let me move above a little bit so you can see what I mean. So this is, you have your rate, you have your concentrations, replace those numbers into the associated equation, and then you calculate your K. Also, in order to be more accurate, you can calculate the K for the different trials. Since they are the same temperature, your K should be a constant value, so you can take the average to determine your K. This is your first approach to determine reaction order and reaction rate constant. The second way, I personally prefer this second way. You are going to plot graphs. So you have your concentrations, you have your rate. You take a logarithm of your rate, take a logarithm of your concentrations for I negative and for hydrogen peroxide. And then you are going to plot a graph. You use your logarithm of rate as your y-axis. You use your logarithm of concentrations as your x-axis. In order to determine your reaction rate order of iodide, you choose this number 5 to 8. This, in my case, will be concentration I5 to I8. Otherwise, this I4, the other two, they're all the same. Choose one of them. And then you plot a graph. From this graph, I suggest use the chart, plot the scattered XY. I think people also call it bubble chart. And then you are going to determine the best fit line. So in this case, you add the trend line. Click any point, add your trend line. So add your trend line and then display the equation, display R squared. This slope is the reaction order for that reactant. In your case, it's for your iodide, I negative. And then you are going to determine the reaction order for hydrogen peroxide similarly. But you use different groups of data. You use your J8 to 11, use the other 4 or 5, as long as you have different concentrations of your hydrogen peroxide. And then similarly, you plot a graph using logarithm of rate as your y, logarithm of concentration of hydrogen peroxide as your x. You find the best fit line. Determine the slope. The slope is your reaction rate order for that, the reaction order for that reactant. So you determine P and Q. And then you are going to do the same thing. You are going to use any trial or all these 7 trials. You calculate the 7 rate constants and then you take the average to determine the rate constant. And the third topic is about activation energy. Activation energy related to the particular reaction, you are going to determine different temperatures. So in our case, I made up this data. Those data do not reflect your real virtual experimental results. I made it up. Simply, I just come up with some numbers. And then you are doing this 0 Celsius, 25, all the way to 180 Celsius. You are going to plot a graph using your ln K as your y. Ln K. This smaller k represent rate constant. So you calculated the same way as what you did from the previous one. So you, first of all, you need to convert the temperature from Celsius to Kelvin. Make sure you use absolute temperature. And then you are going to calculate the rate constant for different temperatures. This K, you calculated the same way as what you did for the previous, for this different groups. You calculated the same way. And then you are going to plot the ln K as a function of 1 divided by temperature. 1 over absolute temperature reciprocal, and then you plot another graph by these two groups of data. Also, you find your best fit line. The slope equals to the activation energy divided by R negative value. So slope equals to the negative EA divided by ideal gas constant. Your EA, activation energy, can be calculated using negative slope times by your ideal gas constant. This ideal gas constant is used 8.134 joules per mole per Kelvin. Be careful with this unit. You may need to convert the activation energy from joules per mole to kilojoules per mole. You will find about a couple thousand kilojoules per mole. So that's essentially is about the reaction rate law determination. You want to determine the reaction order for different reactants. You also want to determine the rate constant for that related reaction at a different temperature. Based on the different temperature, you can calculate the activation energy. Followed by, you see these diagrams. I technically listed all these reaction orders: zeroth order, first order, second order, the rate law, unit for the K. You need this unit. Our case, your overall reaction rate order is 2P plus Q. That's the overall reaction order. And then also I gave you the integrated rate law. How do you determine the best fit line, and what does this slope and y-intercept represent? So this slide is also from your PPT, PowerPoint lecture notes. Thank you again for listening. Have a beautiful day. Stay safe and be happy. Bye-bye.